Hello and welcome to the Fossil Huntress podcast. I hope you guys are all doing really well. Today on the show we are joined by Dr. Victoria Arbour. She is the curator of paleontology at the Royal BC Museum, and she is a vertebrate paleontologist, an evolutionary biologist, and one of the leading experts on the palaeobiology of our armoured dinosaurs that you'll know as ankylosaurs. So she has just finished a wonderful field season up in northern BC in the Carbon Creek Basin, so it's just west of Hudson's Hope in the Peace River region, and it's a site that boasts nearly 1,200 dinosaur tracks from at least 12 different dinosaur species, including 2 dinosaur track types that have not been observed in any of the other sites in the Peace region. So this was presented as a slide set, so you're going to hear the audio, and you'll find the slides over on the Fossil Huntress Archaea YouTube channel in short order, but I thought I would share her talk with all of you. So thank you everyone for joining us at the Vancouver Island Paleontological Society lecture series. I will introduce Dan Bowen, who is the chair of both the BCPA, the British Columbia Paleo Alliance, and the VIPS, the Vancouver Island Paleo Society. And then I will have him pass it back to me to introduce Victoria. So say hello, Dan.
Yeah, thank you, Heidi. And a quick thanks to Victoria for making time. I know she's very, very busy and has many things going on in her life. And really happy that you were able to make the effort to do a presentation today. So thank you, and I'll put it back to Heidi. Thanks.
There we go. So we are joined by Victoria Arbour, who is a vertebrate paleontologist and evolutionary biologist. She is the curator of paleontology at the Royal BC Museum in Victoria, and she has an enviable life working on some of the most exciting finds. She is a specialist in our armoured dinosaurs, the ankylosaurs, and most recently she returns from the field, about to be a mama yet again, and she has been playing in the Peace River region, where she's been working with over 1,200 dinosaur trackway sites. So it'll be the Coal Basin in the Peace region, and I turn it over to Victoria, and I will mute myself till the end. So thank you so much.
Yeah, thanks everybody. I'm gonna attempt to share my screen, which I never seem to get right despite doing this for like 3 years now. So let's see if I can do this the right way. Okay, we want to do maybe just share the entire screen. Share, and then you guys are gonna see all kinds of stuff. All right, is everyone able to see my screen? Okay, thank you for the nods. I appreciate it. Okay, perfect. So yeah, today I just wanted to give just a bit of an update about what the Royal BC Museum got up to this summer, mostly with the focus on our work up in the Peace region. We initially had 3 field projects planned for this summer. A secret one that I can't talk about yet, but hopefully in a year or so I'll be able to. This project that I'm talking about today, and then also a continuation of our fieldwork on the Spatsizi Plateau, where we're looking for dinosaur bones in the Sustet Basin. Unfortunately, so if you had been to the BCPA symposium, you probably heard me give a talk about that. We were really excited about it, and about 5 days beforehand, we had to cancel the whole thing because there was a wildfire exactly where we put our tents. So that was a huge bummer, but we got a chance to get up and do some field work up in the Peace region, which was really great. So that's what I wanted to talk about today, sort of a new project for us. The fossils that I'm talking about today are found on Treaty 8 territory, and in particular, the Saulteaux First Nation are the guardians of the land that the Tracksite is on. And we're really appreciative of the permission to conduct research on this land. We were joined by one of the elders from the Saulteaux First Nation, Tom Aird, who came out with us for about 5 days, and we got to share what we were doing, and he shared lots and lots of information about Saulteaux culture, and it was just really great. And we're really excited about the opportunities to collaborate on this project going forward, because we anticipate that this is going to be at least a 5-year plus project that we'll be working on for a while. So if we think about dinosaurs in BC, I like dinosaurs, and there are dinosaur bones in BC, but the skeletal fossil record is still not that great. It's getting better, and I think it's just going to take a lot of work and a lot of like dedicated time building on what people like Rich McRae and Lisa Buckley were doing previously. So although we have some bones, our fossil record is not great. So we've got some scrappy material from the latest Cretaceous from the Sustut Basin. There's a little bit of material known from the Wapiti Formation, so in the Campanian. We've got the occasional bone that pops up on Vancouver Island, and then we've got a little bit again from the Peace region in terms of like the Turonian and Cenomanian. But these are all like very fragmentary, like bits and pieces. But our footprint record is excellent, as I'm sure many people here are probably aware of. And our footprint record both has an incredible diversity of dinosaurs represented, but also stretches over a really, really long period of time, which is one of the things that I really love about working in BC, is that we're not just looking at the last, say, 20 million years, the Campanian Maastrichtian. We actually have basically the entire Cretaceous represented, and possibly even into the Jurassic, which is really cool. And although footprints can't exactly tell you what you are, the specific species of dinosaur, they do give you a pretty good idea of the general type of dinosaur, and certainly can give you insights into how the faunas are changing through time. So just from the footprint record alone, we can see that there's some pretty major changes, that we've got sauropods in BC in the early Cretaceous and not in the later Cretaceous, that we've got ankylosaurs pretty much all the way through, which is cool. And so this is one of the things that I'm really interested in sort of the long-term research program I'm trying to build up, funded by NSERC, is looking at these big transitions during the Cretaceous, which is a time where we've got multiple like sea level transgressions and regressions. We've got the origin and sort of rise to dominance of flowering plants. And there's major changes in dinosaur faunas going from kind of like sauropod dominated in the early Cretaceous to like hadrosaur and ceratopsian dominated in the late Cretaceous. So there's a lot of change going on basically. So and BC is a really interesting place to actually look at those changes. So the fieldwork that we were doing and that I'm talking about today, which is footprint focused, is in the Peace region. So for anyone who doesn't know exactly where Hudson's Hope is the closest town. It's north of Prince George. It's north of Chetwynd, and it's basically sort of the little gateway to the WAC Bennett Dam that creates the Williston Lake Reservoir, and the big sort of hydro plants associated with it. So our tracksite is basically just south of Williston Lake, in that area. And this region is actually really well known for footprints for a long time. So at least dating back to like 1930 when it was first published, and obviously the fieldwork happened before then. Sternberg documented a lot of dinosaur tracks from the sort of canyons along the Peace River before it was flooded. Multiple new species are described in this particular paper. I think at least like 6 new species of dinosaur footprints were described, that have now since been found like elsewhere in the world. So it's a pretty historically important area, both for paleontology in BC and Canada, and also just for like footprint taxonomy as well. That work happened in sort of like the late 1920s, published in 1930. Then not too much happened with this area for a really long time until the Peace River became the site where the big hydro projects were going to be installed, and all of these sites would be flooded. And so that's where the Provincial Museum of Alberta comes in. This was actually one of Phil Curry's first big field projects, was working in BC. Phil was my supervisor as a PhD and master's student, so it feels kind of like I've come full circle on some of this stuff. And so many of the projects that he led in sort of the late 70s through 80s we're basically doing mitigation paleontology to document as much of this as possible before the sites would be lost and flooded under the dam. So he wrote several papers. There were hundreds and hundreds of tracks documented and photographed. Many were collected, many molds and casts were collected. Most of those are not actually located in BC, though, unfortunately. So quite a few of the tracks are part of the Royal Trail Museum's collections. And what Derek and I have also learned is that there were some set aside for the BC Provincial Museum that we think are probably still at the Tyrrell. So hopefully at some point in the future, we'll go over to those guys and have some conversations about what is potentially meant to be here, or if it's not meant to be here, what we could do in terms of like sharing of some of these historical specimens. So yeah, and hopefully when we're at our new collections and research building, we'll actually have the capacity to take dinosaur footprints at this scale that they are potentially at, which is cool. And then of course the dam was built and all of those track sites were flooded, and basically all of the Peace River track sites are gone. They're underwater now and not accessible. What's interesting is that back in 2000, in the sort of, adjacent to Williston Lake and the old Peace River Canyon, an archaeologist actually discovered a site that is not near water at all. This is a site that had been revealed through forestry practices. So a bunch of trees and land had been cleared to basically be like a staging area for logging. And he noticed that there were some footprints peeking out of some of the exposed rock. So that was in about 2000. His name was Barry Moreau. He didn't really know that they were that interesting or significant till he visited the Tumbler Ridge Museum and told Rich and Lisa about it back in 2008. And then it took them a few years to get sort of the funding and the organization to go do a large scale research project on this, which they did in sort of 2016 and 2017. So Rich and Lisa have moved on to some other projects now, and so the site has been kind of laying fallow for a couple of years. So last year I went up to Tumbler Ridge and had lots of chats with people about what we want the future of this site to look like, because it's actually incredibly significant, both in terms of having lots of interesting footprints, but also because of what is preserved at the site, which I'll talk about in a few minutes. And so this is just a quick overview of the scope of the site. I'm not actually showing the entire track surface. We're currently calling this site the Carbon Creek track site, but it has previously been referred to as the Six Peaks Dinosaur track site, if anyone's heard of that, but the new name is currently Carbon Creek. And the Saulteaux First Nation are actually probably going to give it a new name for us. So I'll sort of update everyone when that happens eventually. The chunk of sort of area at the bottom that's nice and clean is the area that has been exposed by either logging practices or Rich and Lisa's teams. And this rubbly area in front represents maybe like maximum a meter and probably a lot less of overburden over presumed continued track surface as well. And so it's a huge site. It's one of the biggest like track surfaces I've seen, certainly the biggest for Canada. And I haven't really seen anything else like this anywhere else in Canada, which is pretty exciting. And notably, it is horizontal, which is great because it means you can actually access the footprints, unlike many of the other sites in BC and northwestern Alberta, which are like vertical or almost vertical. This is the same formation as the Peace River Canyon footprints. This is all part of the Gething Formation, which is about 110, 120 million years old. So sort of early to mid Cretaceous. This photo I took in 2019 during a visit by the Canadian Society of Vertebrate Paleontology. So there's about 20 or 30 very excited vertebrate paleontologists running around and getting excited about dinosaur footprints, which was pretty cool. You may have heard in the news that there was some vandalism at this particular site, although I don't know if the site was specifically named. But there were several footprints cut out of the site a couple of years ago. And this was actually one of the first instances where the dinosaur or the fossil management framework was actually put into place and used to prosecute someone. So several people actually were fined pretty hefty fines and sent to jail for a period of time because of the vandalism that happened at this site. It is a designated protected site, but also just in general, like all fossils are now protected in the province through the Land Act. So vandalism like this wouldn't be okay anywhere. It's just extra super duper not okay at this particular protected site. the vandalism has made us all a bit nervous about the future of the site. And so that's partly why there is some desire to continue the work that Rich and Lisa were doing. And so that's why we're up there now, kind of continuing on. We don't want there to be any more vandalism before the research gets done. And so we're going to try to focus our efforts on this over the next couple of years. It's tricky because it is simultaneously remote and very accessible. So it's really easy for people to if they know it's there. And there really isn't a lot that we can do to stop people from going there because it's just so remote, and there isn't really a practical way to really like barricade or seal off the site at this point. So we usually just try to like remind people that fossils are protected, and we also try to tell people about why it's significant and why it's also very difficult to remove footprints. The people who tried to remove footprints just broke them basically, so they didn't even really get anything good out of it for themselves. So so these are all things we have to consider. Okay, so that leads us to this year. So in August of this year, I took a crew of people from the Royal BC Museum and University of Victoria. So Emily, Teague, and Andrea are all students that I supervise through my adjunct status at UVic. Emily and Teague are master students, and Andrea is an undergrad who's actually moving on to the ROM starting in January, which is great. And then some of you will have met Derek and possibly Kala before. So Derek is the collections manager in paleontology at the museum, and Kala is our fossil preparator. So the six of us drove up from Victoria up to Hudson's Hope and stayed at Williston Lake Lodge, which was pretty cool. And then we got to drive back and forth across the dam every day. So it's about an hour's drive. The other option was to camp right at the site, but we had a lot fewer amenities and we weren't really sure about sort of safety and things like that. So staying at the lodge and having a bit of a drive every day wasn't so bad. This is Derek expertly taking us across the dam. If you've never been to that area before, it is pretty impressive, even if it's maybe not environmentally or culturally really great, but it is certainly an interesting feat of engineering. So we would cross the dam every day and then drive along a sort of rough logging road that made us pop 2 tires over the course of our trip. But that's why we just have the PAL tire on speed dial, I think maybe for next year. And then we are able to sort of park just off the logging road and walk up a small sort of ATV trail. And then we're at the site. So it's actually not too hard to get to, which is, like I said, sort of both a blessing and a curse. This is just an overview of what a like typical moment at the Tracksite looked like while we were there. In addition to the sort of 6 core team members, like I said, we also had Tom Aird from the Saulteaux First Nation. And then we had 2 folks from Tumbler Ridge join us as well. Birgit, who was from the Tumbler Ridge Museum board, and then Roy from the Tumbler Ridge Global Geopark. He's their sedimentologist. They came out for 2 days with us as well. So we had up to like 8 people, which was, or 9 people, which was pretty nice. Although we could actually absorb more when we're up there. Yeah, so we had lots of different projects on the go while we were there. And I thought I would just kind of walk through like some of the types of work we were doing, and then I'll talk about the footprints themselves. So we end up having like lots of gear that we need to do for trackway projects. So it's a little bit different than digging up a dinosaur bone bed, but there's also a lot of similarities. That big sort of grid that you saw was our mapping grid square. We end up using lots of like brooms and brushes to just clear the surface off. We did do some excavating to see how hard it was and what would be involved. We've got first aid kits, lots of notebooks, and then those little yellow and blue buckets are our silicone molding supplies. You can see it's all very organized at the site while we're there during the daytime, so that's good. A big part of what we were doing was mapping the exposed track surface. So that was sort of our big goal this year, was to basically map as much as we could. I think we ended up mapping about 150 square meters, and there's still lots to go. It's a bit of a slow process. We basically, Rich and Lisa had laid out a grid coordinate system with little X's, we realized. So we were actually able to reuse their sort of coordinate system. And then what we do is we use this mapping square, which is a meter by meter. And then we are able to basically sort of drop a plumb bob down and draw little points onto our grid paper, and then we've got our map. So we wind up with notes like this. Each of these sort of four squares represents one grid square, and we're basically drawing everything that we see. So all of the footprints, any sort of notable cracks, any other like sedimentary structures we think are interesting. And then each of those footprints gets a little number based on its grid coordinates, and those go into my notebook with measurements and any observations about how well it's preserved. And in the end, we end up with like a big pile of pieces of paper. Eventually, those hand-drawn maps will get scanned in, and I will redraw them digitally, and we'll have a whole map of the surface of the track site, which will be really interesting to interpret. The other thing that we did, which was new for me, I have not actually done a lot of this before, was we did some molding of some of the footprints that are on the surface. So we didn't want to collect any original footprints from this site, because really what's interesting about this site in particular is how the footprints are arranged in relation to each other. And that's true of many like track surfaces. But it's really nice to be able to bring at least a few of the footprints back represented in our collection, so that we've got a record of like what taxa are here, or any with like really interesting preservation. And so as the footprints sort of erode or are left behind when we're done the project, we'll at least have a record in the museum. And so we're using silicone molding because it's nice and archival for sort of long stability in our collection. We're using a brand called Smooth On, and they have pourable silicones, but we were using a brushable one as well. And so Kala sort of took the lead on this, and the students did lots of help. But basically, we would mix up two different of these silicone molding compounds. The pink layer that you're seeing here is the sort of more flexible one to get into all the little like crevices. And then we put a blue layer on that's a little bit more firm. We usually had to do about 4 layers and then put a plaster and burlap backing on things, which you can see in this particular image. And that gives the mold its rigid shape when we're carrying it out and back at the museum. And so basically it takes about a day to make one of these. You can have several on the go at the same time, but it takes about a full day to get one footprint mold completed. We have to do at least 4 layers, we realized, for it to be nice and durable feeling, and we probably could even do more. And then we've got to do the plaster and burlap layer. It takes about an hour for the silicone to set each time. And then it takes at least an hour for the burlap to be sort of nice and set and not sort of damp and squishy feeling. And so, yeah, so by the time you factor all of that in, that's pretty much your day. At the end of the day, we then had got to do the fun job of peeling it off. So right now, Kala and Andrea and Emily are just using some like wood shaving tools to pry up the hard burlap and plaster mix, and I think it's going to pop off pretty much any time now. And then once that pops off, the mold is underneath, and then they get to work on pulling the mold up. I want to hold on until they actually pull it up because it's very satisfying. But it also takes a lot of work because we don't want to break it. Oh yeah, there we go. So we just move that little shell off to the side, and then they begin the process of very carefully peeling it up, both so that we don't destroy the footprint underneath and we don't tear the silicone itself either. And it can be fairly sticky, but it doesn't actually leave a lot of residue at the end. Sometimes there's some little bits. The plaster leaves a bit more of a mess. We usually tried to clean that up at the end. We would sort of pick it off and then use some brushes and water. And we're hoping that over the winter, it'll basically just wash away. You won't even really know it was there. So the silicone molds are great. I think we collected about 8 of them in the end, which was sort of a good amount for our first try, trying to get representative different things. But the other technique that we can use for documenting and making copies of footprints is photogrammetry, which some of you may have done before, but if you haven't, it's basically just involves taking tons and tons and tons of photos at different angles of whatever object you want to model in the computer. And so Andrea here is actually walking up a trackway made by a sauropod, which I'll talk more about in a few minutes. And what the nice thing about this is we're not constrained by size. So we didn't mold any of these large sauropod footprints this year because we weren't sure we would actually have space to take them back. But we did do lots of digital modeling of the footprints so that we have records of them back at the museum and for doing research on. But the nice thing about photogrammetry is that you are not limited really in terms of size. So once we have all of those photos, I have a piece of software called Agisoft Metashape. And it's relatively easy, although sometimes it's a bit picky, but here's basically our sauropod trackway using all of those photos. And this is a huge surface. You can see our grid square kind of up in the corner in the still image. That's a meter, so that gives you an idea of just how long that surface is. And at some point, we hope to actually maybe photogrammetry the entire surface using a drone, which would be really cool. So while we were there, we also did a little bit of a test excavation. So part of the site had already been uncovered and cleaned up by Rich and Lisa, and just by like the logging activities. And then there's still quite a lot of area that has kind of this rubble over it. So there's kind of broken up, weathering, mudstones and sandstones. And we wanted to see if we wanted to expose more surface, exactly how much effort that would take. So we weren't really aiming to uncover a large amount. It really was so we could kind of come back and make a calculation that's like, it took X number of people this many hours to uncover 10 square meters. So if we want to uncover the whole surface, it'll take us 5 years or something like that. So we were able to do that, which was great. So this is a combination of pickaxing, shoveling, and then getting in with some finer tools for the last layer or two. What we learned was that while it is work to uncover new footprints pretty quickly at this site, what we found was that a lot of the trees and I think it's the alders that are growing in on that surface, their roots like to find all of the bedding planes in the rock, which is actually helping us like lift things off. So there's basically a last hard layer that we can pry off in big chunks sometimes. And then we're basically down at the footprints where we just have to clean them out a little bit with brushes and hammers and chisels. And so, yeah, so what we're hoping is that next summer we might actually sort of expand our crew a little bit and really focus on uncovering more of the track surface while also simultaneously documenting, like continuing to document what's already there, which is cool. It's nice to do some digging after a lot of years of not digging. So every day we would head out at about 8 in the morning, drive out to the site, try to come back sometime between 6 and 7 in the evening. We were, Derek, Cal, and I were staying up at the lodge, and they also have a campground where the students were, and that's where we would set up to cook. So we had our little communal dinners every night. And then the evenings were usually spent catching up on our notes and also doing a lot of our photogrammetry processing back in the lodge. So another good reason to be able to have access to electricity, and just making sure that our photos actually were going to result in a successful model, because it doesn't always. So that was like a typical day. And now let's talk about some of the footprints that are present at the site. So the site has hundreds and hundreds and hundreds of footprints already exposed, and I'm like, literally thousands if we were to uncover the entire potential track surface. One of the more abundant footprints are these large theropod prints that are pretty common all over the site, sometimes just isolated, often in pretty identifiable trackways. So that's my foot for scale. So that's a pretty decently sized animal. The footprint itself is called Irenosaurus, and the best guess is that it is a large theropod, probably a large carcharodontosaurid, just based on what exists elsewhere in North America at that time. And so the closest sort of genus of dinosaur is Acrocanthosaurus. So potentially an Acrocanthosaurus like theropod, which is this big carcharodontosaurid with kind of tall neural spines on its back. And so that's probably one of the most common tracks that we see at this particular site. We also have lots of far fewer examples of some kind of small theropod that seems to have narrower toes and a bit more of a splay to the foot. And this is probably the ichnogenus Columbosauropus. It is not clear what dinosaur made this, but we know it is some kind of small theropod or small meat eater. At this time, possible candidates are actually small tyrannosaurs. And so the ancestors of Tyrannosaurs are present at this time, but they are small and not like the apex predators that they will become eventually. So that's one possible potential track maker. Other options are possibly small ornithomimids, or other coelurosaurs of indeterminate affinity. One of the track makers I'm really excited about is that there is a record of not one but two large sauropods here. So there is one sauropod trackway sort of that we can follow here. So you see these big divots in the ground; those are the sauropod's feet. And then there is another one that crosses it back in the back corner of that particular photo. So we don't know exactly what ichnogenus of sauropod this is. That's something that still needs to be determined. But it's really cool because sauropod skeletal fossils are not known in BC, and sauropod fossils at all are not known anywhere else in Canada except BC. And so this is actually really cool. The only other places that we get sauropod footprints are the mines in the southeast of BC, like the Teck mines mining for coal. And those are actually much older than these. So this is only the second occurrence of sauropods, and it's the youngest occurrence of sauropods in British Columbia. So I think that's really cool. I'd love to get a student working on these and thinking more about sauropod footprints in BC. My student Teague Dixon is doing their master's project on four-toed theropod footprints. So most theropods leave three-toed footprints, and there's a couple, most notably oviraptorosaurs and therizinosaurs, that can leave four toes pressed into the ground. And we have several examples of a four-toed theropod at the Carbon Creek Tracksite. So Teague spent a lot of time doing measurements and observations and thinking about this footprint and the other ones like it at the Tracksite. And hopefully maybe they can even give a presentation for you guys next year once we get a paper submitted over the winter talking about what exactly this thing is, which we're pretty excited about. I would say the second most abundant dinosaur footprint that we see at the Carbon Creek Tracksite are these three-toed, sort of chunkier toe footprints that are referable to the ichnogenus Gypsicnites. And there is not good consensus on what Gypsicnites is or who it was made by. There's actually some debate about whether or not it's made by a theropod or a ornithischian or an ornithopod. We think we've seen some manus prints, so hand prints, which would suggest it's an ornithopod, but it's not always super clear at this site. So our best guess is it's probably an ornithischian and a small ornithopod, Camptosaurus, which would be alive at approximately this time elsewhere in North America. So Camptosaurus is a potential or some kind of small ornithopod, or medium-sized ornithopod. There are tons of obvious trackways for Gypsicnites. And what's really fun is that many of the footprints actually preserve a metatarsal or ankle impression or heel impression, which suggests that they're sort of sinking into the mud at various points while they're walking across the surface. And there's even a few where it looks a bit like they've slipped a bit, which is pretty cool. And finally, we've got a large ornithopod leaving big three-toed chunky footprints. The ichnogenus is Amblyodactylus. And this is probably an iguanodont, like Iguanodon or similar. In North America around this time, there are some big iguanodonts like Hippodraco and Iguanocolossus, things that were previously sort of referred to as just Iguanodon, but from North America. And so we've got at least one really long trackway of Amblyodactylus at this site, which is pretty cool. There are also a couple of like odd things that we've seen impressions of that could be, excuse me, bird or pterosaur prints, but we're not too sure about those yet, so I haven't put them in here, but it's possible we've also got some birds or pterosaurs represented at the site as well. Something that is weirdly absent, in my opinion, is the ichnogenus Tetrapodosaurus. Tragically, because these are made by ankylosaurs, which are my favorite dinosaurs. And Tetrapodosaurus is known from the Gething Formation. This genus was named by Sternberg from Peace River Canyon fossils. And despite there being just hundreds of footprints across this site, there is nothing that is even remotely possibly considered Tetrapodosaurus. So possibly if we excavate more of the site, we will see them, or that might tell us something interesting about just the environment or habitat of the site and why we aren't getting ankylosaurs there, which is pretty weird. So overall, at this point, we know that we've got a small ornithopod and a big ornithopod, a small theropod and a big theropod, a big sauropod, a mystery theropod that leaves four-toed footprints, and maybe some birds and pterosaurs. So we're actually getting a pretty good read on the diversity of the site so far, and I'm sure that more will be revealed as we keep investigating and studying this. We're pretty sure that this is going to need to be at least a 5-year project just to really thoroughly document everything that we've seen and uncover a little bit more and actually get more of the picture of what's there. And in addition to just seeing what dinosaurs are here, there's a lot of questions about the site that are going to take a long time, I think, for us to figure out. Why are all these different species here? Are they being drawn to a specific resource like water or food or a clay lick or something like that? How long a time span does this site really represent? Is it a couple of days? Is it a couple of weeks? What's the paleo environment like? Is it underwater? Is it is it adjacent to water? We have seen some plant fossils, and we've also got some invertebrate fossils from the site, so there's some work to do there to interpret those. Yeah, and then sort of pulling out more broadly, what does the site tell us about how dinosaurs are changing and evolving in BC and in North America at this time period? So there's just so many projects for us to do, and we really just were there for like 10 or 11 days this year, and we've already got so much data. So I'm pretty excited about what a really dedicated focus over the next few years will let us do. And I just want to share a couple of other projects that we did while we were up in the Peace region before I throw it out to questions.